Hello students and friends. So continuing with quadratic equations, solving the problems from the NCERT Exemplar exercise 4.2. So the first question states that state whether the following quadratic equations have two distinct real roots. Now we know that the general form of the quadratic equation is ax square plus bx plus c equal to 0. And there you have the discriminant equals b square minus 4ac. By calculating the value of the discriminant, we can identify whether the roots are real or distinct. So if b square minus 4ac is greater than 0, then the roots are real and distinct. If it is equal to 0, the roots are real and equal. And if b square minus 4ac is less than 0, then there are no real roots or the roots are imaginary. So let's begin with the first problem. So do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads. So question 1, x square minus 3x plus 4 equal to 0. So in all these questions 1 to 10, we only have to identify the value of b square minus 4ac. So a is 1, coefficient of x square, b is minus 3, coefficient of x, c is 4. So what is b square minus 4ac? Minus 3 the whole square minus 4 into 1 into 4. So you have 9 minus 16, which is minus 7, which is less than 0. So the roots are imaginary. So it has no real and distinct roots. So the roots are imaginary. So the question states that we have to identify whether the equations have two distinct real roots. So the answer is no for the first one. Second one, 2x square plus x minus 1 equal to 0. So again comparing the equation with ax square plus bx plus c, a equals 2, b equals 1, c equals minus 1. So find the discriminant d, which is b square, 1 square minus 4 into 2 into minus 1. So you have 1 minus into minus is plus, 4 into 2 is 8, plus 8, which is equal to 9 greater than 0. So yes, the roots are real and distinct. 3, 2x square minus 6x plus 9 by 2 equals 0. So again comparing it with ax square plus bx plus c equal to 0. A equals 2, b equals minus 6, c equals 9 by 2. So b square is minus 6 the whole square minus 4 into 2 into c is 9 by 2, 2 gets cancelled. So you have 36 minus 9 4s are 36, which is equal to 0. So you have real and equal roots here. So therefore the roots are not real and distinct. Fourth one, 3x square minus 4x plus 1 equals 0. So again a equals 3, b equals minus 4, c equals 1. So b square is minus 4 square minus 4 into 3 into c is 1. So you have 16 minus 12, which is 4 greater than 0. So it is real and distinct. Right, so I put a tick mark here. Fifth one, so we have x plus 4 the whole square minus 8x equal to 0. So here I need to apply a plus b whole square. So x square plus 2ab is 8x plus 16 is b square minus 8x equal to 0. So plus 8x minus 8x gets cancelled. So here what is a? A is 1, coefficient of x square, b is 0 and c is 16. So b square minus 4ac, 0 minus 4 into 1 into 16, which is minus 64 less than 0. So therefore the roots are imaginary, so therefore they are not real and distinct. Sixth one, x minus root 2 the whole square minus root 2 into x plus 1 equal to 0. So here I need to use a minus b whole square. So you have a square minus 2 into root 2x plus 2. Root 2 square is 2 minus root 2x plus root 2 into minus 1. So this is minus root 2 equal to 0. Right? So here you have 2 root 2 and then minus root 2x. So it's x square minus 3 root 2x plus 2 minus root 2 equals 0. So a is 1, b is minus 3 root 2 and c is 2 minus root 2. So b square is minus 3 root 2 the whole square minus 4 into 1 into c is 2 minus root 2. So square this, so you get 9 into 2, 18 minus 4 into 2 minus 4 into root 2. So I have not opened the bracket, so let me keep it as it is. 18 minus 8 plus 4 root 2. So you get 10 plus 4 root 2. Of course, the value is greater than 0. So the roots are real and distinct. Seventh one, root 2x square minus 3 by root 2x plus 1 by root 2 equals 0. So again a is root 2, b is minus 3 by root 2 and then you have c equals 1 by root 2. b square minus 4ac, so b square is 9 by 2 minus 4 into a into c. So root 2 gets cancelled. So 9 by 2, what is 9 by 2? It is 4.5 minus 4, which is 0.5, which is again greater than 0. So the roots are real and distinct. Eighth one, x into 1 minus x minus 2 equal to 0. So I need to multiply. X into 1 is x, x into minus x is minus x square minus 2 equals 0. So let me take minus sign throughout. So you get x square minus x plus 2 equals 0. And a is 1, b is minus 1, c is 2. So b square is minus 1 square, b square minus 4 into a into c. So you get 1 minus 8, which is minus 7. So they are imaginary, right? So the roots are imaginary, so they are not real and distinct. Ninth one, you have the equation x minus 1 into x plus 2 equals 0. So multiply. X into x is x square minus x plus 2x minus 2 plus 2 equal to 0, right? So minus 2 plus 2 gets cancelled. So here you get x square plus x equals 0. So a is 1, b is also 1, c is 0. So what is b square? B square is 1 square minus 4 into a into c, which is 0, which is 1 greater than 0. So the roots are real and distinct. So I'll put a tick here. Very simple problem. Next one, x plus 1 into x minus 2 plus x is equal to 0. So again multiply these two, you get x square plus x minus 2x minus 2 plus x equals 0. So plus 2x minus 2x gets cancelled. So we have left with x square minus 2 equals 0. So a equals 1, b equals 0, c equals minus 2. B square is 0 square minus 4 into 1 into minus 2. Minus into minus is plus, so you get 8, which is greater than 0. Roots are real and distinct. So you get 8 as the value of the discriminant. So this completes all the 10 subsections of question 1. So question 2 is very interesting. So you have to identify whether the statements are true or false. So the first statement, every quadratic equation has exactly one root. So this is a false statement because every quadratic equation has 2 and only 2 roots. So this is a false statement. So what is the right answer? You have 2 roots because quadratic equation is of the form ax square plus bx plus c. So you have 2 roots. So the first statement is false. The second one, every quadratic equation has at least one real root. So at least one real root. So this again is a false statement. Why? Because if the discriminant is less than 0, then the roots are imaginary. Both the roots are non-real. So this again is a false statement. Third one, every quadratic equation has at least 2 roots. So you have at least 2 roots. So what do you mean by at least 2 roots? That means minimum you may have 2 roots, but you can have more than 2. So we come across such statements especially in probability, right? So when you say that an equation has at least 2 roots, that means minimum you have 2 roots, but you can also have more than 2, which is again a false statement, because a quadratic equation only has 2 roots. So this again is a false statement. Fourth one, every quadratic equation has at most 2 roots. So we can say that this is a true statement because every quadratic equation at least or at most has 2 roots, which is true. So at most, a maximum of only 2 roots, which is a true statement. Fifth one, if the coefficient of x square and the constant term have opposite signs, then the quadratic equation has real roots. So let us observe. Here the coefficient of x square is a and the constant term is c. And we have the discriminant b square minus 4ac. So the question is, if they have opposite sign, if a is plus and c is minus, then we get b square plus 4ac because c is minus here. Okay. For this case, plus a minus c, you get b square plus 4ac, which is greater than 0. So you have real roots. Now if you have minus a and plus c, again you get b square minus 4 into minus a into c, again you get b square plus 4ac, which is greater than 0. So you would get real and distinct roots. So if the coefficient of x square and the constant term c, they have opposite signs, then the quadratic equation has real roots, so which is a true statement. So this is true. Sixth one, if the coefficient of x square, which is a, and the constant term c have the same sign, then the quadratic equation has no real roots. No real roots. So is it true? So let's check out. So these two have the same sign, right? That means if a is plus and c is plus, so you get b square minus 4, a into c, both of them are plus. Okay, so in this case what happens? So not only is the sign of a and c the same, but there's one more condition given, that if the coefficient of x term is 0, that means b equals 0. So a is positive, c is positive, and if b equals 0, then you get minus 4ac, right? So it is imaginary, less than 0. If a is negative and c is negative, b is 0, right? So you get 0 minus 4 into minus a minus c. So again you get minus 4ac because you have 3 negative signs, which is again less than 0. So in both the cases, the roots are imaginary. That means you have no real roots. So which is a true statement? So when are the roots imaginary? If a and c have the same sign, and if the coefficient of x, which is b, if it is 0, then you have imaginary roots because the discriminant will be less than 0. So this completes question 2. A quadratic equation with integral coefficients has integral roots. So you have to justify the answer. So let's take an example. So what does this mean? Suppose you have quadratic equation, say 2x square minus 3x minus 5 equals 0. So here it's been given that you have integral coefficients. That means the coefficient of x square, the coefficient of x, they are all integers, and then the roots, what you get, will also be integers. So is it true? We have to justify the answer. So I've taken an example here. Okay, so a is 2, they are all integers, b is minus 3, c equals minus 5. So let's find out the root. you have x equals minus b, which is minus of minus 3, which is plus 3, plus or minus root of b square, minus 3 whole square is 9, minus 4 into 2 into minus 5, divided by 2 into 2. So you get 3 plus or minus root of, so observe here it is 9 plus 8 into 5, 40 by 4. So you get 3 plus or minus root 49 by 4. So root 49 is 7. So you get two roots, 3 plus 7 by 4 and 3 minus 7 by 4. Right? So what is 3 plus 7 by 4? 10 by 4. And here it is minus 4 by 4, which is minus 1. So you get 5 by 2 and minus 1. Now the coefficients are integers, but I find that the roots are not integers. So it can happen that the roots may not be integers. So therefore the answer is no. So just because the coefficients of x square and x are integers, it doesn't mean that the roots are integers. So here we have got a case where you get 5 by 2, which is a fraction, and it is not an integer. Fourth one, does there exist a quadratic equation whose coefficients are rational but both its roots are irrational? So coefficients are rational, but the roots are irrational. So let's take an example. 2x square plus x minus 4 equals 0. So what are the roots? A equals 2, B equals 1, C equals minus 4. So x equals minus b, right? Plus or minus root of b square minus 4 into 2 into c divided by 4, 2a. So you have minus 1 plus or minus root of. So here you have 1. So minus into minus is plus. So 16 into 2 is 32 plus 1 is 33 by 4. Right? So here you have the roots minus 1 plus root 33 by 4 and minus 1 minus root 33 by 4. Right? So here we have a case where the coefficients are rational but the roots are irrational. So is there a possibility? The answer is yes. Fifth one, does there exist a quadratic equation where the coefficients are all distinct irrational but the roots are rational? So let's consider an example. Root 3x square minus 7 root 3x plus 12 root 3 equals 0. So let's try to find the roots of this quadratic equation. So you have a equals root 3, b equals minus 7 root 3 and c equals 12 root 3. So x equals minus b, which is 7 root 3, minus into minus is plus, plus or minus root of b square. So 49 into 3 minus 4 into a into c divided by 2 into root 3. So this is what we get. So you have 7 into root 3 plus or minus. So observe here you have 49 into 3 and then here in this case you have 4 into root 3 is 3. So you get 49 into 3 minus 48 into 3 divided by 2 root 3. So let me take this 3 outside the root. So you get 7 root 3 plus or minus root 3 into root of 49 minus 48. I have taken 3 outside the root. So it becomes root 3 divided by 2 root 3. So root 3 is common, which can be cancelled. So you get 7 plus or minus 49 minus 48 is 1. So root 1 is 1 by 2. So you get 7 plus 1. So the roots are 8 by 2. And 7 minus 1 is 6 by 2. So you get 4 comma 3. So 4 comma 3 are the roots of the quadratic equation. So is it possible that you have a quadratic equation whose coefficients are all distinct irrational? Yes. but then the roots are rational. Yes, of course. So you here in this case the roots are 4 and 3. So is there a possibility? The answer is yes. Sixth one, 0.2 is a root of x square minus 0.4 equal to 0. Justify your answer. So the question is 0.2 a root of x square minus 0.4? Now if a value is a root, if a number is a root of the quadratic equation, if I substitute that value in place of x, then the equation should be equal to 0. So put x equal to 0.2. So you get 0.2 whole square minus 0.4 equals 0. So you get 0.04 minus 0.4, which is definitely not equal to 0. So is 0.2 a root of x square minus 0.4? The answer is no. Seventh one, if b equals 0 and c is less than 0, is it true that you have x square plus bx plus c equal to 0 are numerically equal and opposite in sign? So let's consider the case. You have x square plus bx plus c. B is equal to 0. So you have x square plus c equals 0. So x square equals minus c. So what is x? X is plus or minus root of minus c. So here you find that the value of x is plus minus root of minus c. So they are numerically equal. So numerically the value is equal, but they are opposite in sign. So this is what we have shown. Now this completes all the problems of the exercise 4.2 of the NCERT Exemplar. So do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads. And thanks for watching.